First, I'm Yoann. I'm working as an SRE at Booking.com. And today I'm going to speak about SLOs, but for one specific kind of topic is SLOs for data-related services. Like, we all know how to monitor HTTP services. It's still a challenge, but we know how to do it. When data is involved, it's a bit different. So what are we going to talk? A quick refreshers on SLOs. I think Yanniv this morning helped a lot on that, presenting the error budget and all it brings. So that will be quick. We'll speak about our reservation system. So what we want to do in this talk is to tell you our journey, to tell you how it went, what we did, what was good and wrong. And so we decided to take an actual example, and we'll present the system that we'll use, and then all our journey for that. And then we'll go off the benefits of defining SLOs for all these data-driven services. So SLI, quickly. So what's an SLI? An SLI is just a quantitative metric. So it's a value. As Yanniv said this morning, it's a numerical value, and there is no argument about that. So an example would be like the availability of your service, the success rate of your service, whatever you can imagine as a metric. The SLO is this SLI plus a target. So when they said that SRE as a part of product management in it, that's where it plays a role. Like when you decide on a target, you basically say, my service will do that, and you have the partners in front, and they have to agree with it. So you don't need to get 6 nines if no one wants about it. But if you only provide 2 nines and they want 4, that's kind of a problem. So at Booking, our reservation system is having some scalability numbers. Like we take basically 1.5 million reservations every day. So that's not a lot, but that's a high number for us. And each reservation will be modified quite a few times during its life. And Booking.com is also not a new company. So it's been founded 23 years ago. So if you take this 1.5 million every day, obviously we didn't start at that number. But still, that's a lot of data. That's terabytes of data that we have to store and process. And it's also a lot of servers across 4 data centers. So whatever we do to monitor, it has to scale at some point. So what is our service? Let's make a very, very simple overview of it. We have a reservation service on the left part for you. So when we create a reservation, you all came here. Most of you have a hotel here. So you basically go, I want this hotel. You go there. You modify everything there. We store all the data for your reservation in some kind of storage. It goes. We have some processing in a pipe, and then we store the result in some data nodes. Many data nodes, the data is spread everywhere. But no one is accessing these data nodes. So we have a gateway. So when you do a query to the search service, you will call the gateway. This gateway will call the data nodes. So that's a very, very basic overview of the system, but that's completely enough for our talk today. So I will stick to 2 things. Like when you see green stuff here, that will be HTTP traffic. Okay? So all of this green row, these titles, are HTTP traffic. In yellow will be always the data. So OK, so we didn't need to define SLOs. We're here for that. Let's do it. So we started. And this is our first SLOs. So we basically monitored our service as we would monitor any HTTP service. We just put availability, we just put latency, and some kind of a success rate. Like when you create a reservation, it can fail, it can succeed. It's not depending on your service. Like you have many, many things going behind. So those are like the 4, 5 SLOs we got. We were pretty happy about it. And then, as we said before, SLO is not just a technical metric. It's also a kind of a contract that you get with your clients. So we went to see them with that and see what they had to say. So we went to see the reservation service folks. And they were really happy about it. They had all they wanted. The service was good enough. The metrics were good enough for them. So it was pretty good. So then we went to see the search service, the right part of the pipeline. And those facts were actually not enough. So first, it's the same guys, mostly. So people storing the data and retrieving the data were quite the same. But this time, they were not happy. Like something was missing for them. What was missing, actually? Well, data monitoring. So we have a system, and we monitor it perfectly. So if we respond with a 500, we know something is bad. But we never check the payload when it's actually responding with a 200. We just say, yeah, it's responded, so it works. Those guys do not agree with that, and they are right. They had questions like freshness, like how long it takes for reservation to be available in this search engine. Like, what about the old data? If I think about durability, like some data made 23 years ago, is it still here? Is it still relevant? Can I still use it? Or is my response actually accurate? Like, there's something that is full of meaning. Like, can I trust the system, basically? And you also have several data nodes here. Like, will the system always respond the same way? Because you can be wrong sometimes. That cannot be OK. But if you're sometimes wrong, sometimes right, and it's always changing, that would be hard for people to use. So we started defining SLOs following these requirements, basically. We started with consistency. We did something quite simple. We had a probe that will basically check all the data nodes. It will check the storage and say, OK, all the data nodes respond the same way for these reservations. That's fine. That gives a nice metrics. That goes red when there's a problem. Like, I'm happy. So I go with a Fox and say, OK, let's name this SLO. And that would be something like this, like percentage of reservation being consistent among all nodes. That's not good, actually. Like, that's really not good for two main reasons. The first one is I'm actually exposing the internal of my service. Like, they have to know that there is some data node somewhere, that there's a gateway, but I don't want to explain that to people. It means nothing to them. And if I want to change them, I will have to change my SLO. It's not really a good thing. The second bad thing here is like, it's a percentage of reservations. But which one? Like the new one, the old one, some random reservation? Like, we have no idea of the actual impact of this metric. So we had to rethink it, to redesign it. And we come to something a bit more complex, but quite simple to understand. Basically, so in green is still the HTTP traffic. So when I do a request to the system, I will reach the gateway. The gateway will reach on a data node, get the answer. What we do here is that for a sample of this request, we will play the same request again and again to different data nodes. And we'll then see, do they always respond the same? And put a metric out of that. So that works. That's not simple because, well, you have updates coming all the time. So you have to basically reframe your request a bit, ignore the last minutes, the last hour, depending on your system. But that works well. But the most important part is, what's the message I'm giving? Well, now my SLO is that. X% of search results are consistent. And that's a very different thing, because now, when this goes right, I can say to the guy and say, yeah, you got this result, but you basically could have got a very different result with the same request. I can basically do it down for each client I have, for each person. It's very usable. So I'm pretty happy about this one, and we'll continue for that. They wanted freshness. They wanted to know the time for the data. Well, we had the probe. We discarded it. We reuse it again. It basically does the same thing. Checking the storage, give me a new reservation, compare the data nodes. And I get a message that is pretty good, like X% of reservation now available within a few seconds. So we're happy. We get metrics. We get metrics. They ask durability. They ask accuracy. And at some point, we understood we were going completely the wrong way. Those guys told us, OK, I need metrics for my search service. And we said, OK, we'll do it. And we thought about their search service. So basically, we just discarded 90% of pipeline. We're trying to compare data to a storage that has no monitoring at all. We have no idea what's in there. And we still want to give data. So I won't go into every SLOs, but we did it, basically. So like on the storage part, what we do is, OK, we have 23 years of data. I mean, we cannot process it in real time. So we put everything into Hadoop. And then we have a MapReduce job that will check all the integrity of the data, checking that all reference point to something that exists, that this thing existing is, we can retrieve it, that it works, that every version is in the right order, all this stuff. We can also check the pipeline itself. We basically put everything in the store and just like check, OK, how long it really took. We can check the integrity of the new reservation made or the new updates. So we have many SLOs, and it's actually good because every time there was a problem, one of those metrics was going down. And so we have SLOs that were required. We went to them. It was good, right? So we're happy. We are very happy. All the SLOs are good. Come on, we're happy. We should say it, right? OK. So we're happy until we're not. Like the thing which we said at the beginning, at the very beginning, HTTP traffic, basically, the latency, the availability, the things that were good are now red. And they're not red just for one day, just not for a week. They're red for a long time, and there's nothing we do. It's not a scalability issue. We tried to improve performance. The number got better, but we're still red. And what happened? Well, basically, it's a search engine. So people will do queries of different complexity. And some people will send very, very, very complex queries to our system and saying, yeah, I can do whatever I want, right? So they do the query, but at some point, it took more time to process. And we had no differentiation, nothing. So they just do it, and our number went down. But why availability will go down? Well, those people will basically ask the same request with very complex stuff and put a very low timeout to it. So we'll say, OK, respond to this in 5 milliseconds. Well, I'm abusing, it's just numbers. But the idea is that all of that became red, and just because of the queries themselves, not because of our system. So we had to think a bit how we could monitor that without being red all the time, because this is useless, right? So we went into buckets. That's what we did. Basically, all our queries are labeled. We have a tag for everything. And what we did is that we manually checked them, checked the complexity, and put them into different buckets. So if they weren't very easy to do, well, we put them in the green bucket, like the one on the left. We'll put a very low latency one, let's say 50 milliseconds, for example. And in availability SLO, we will also consider this request as being good and should be included. So more complex queries, we'll do it, put them in another bucket with different SLOs for latency, but we'll have monitoring. The problem is that the work here is manual. And those queries, like 1582 and all the one in those buckets, they represent like a lot of our traffic. They are big users. So we're happy, it's very easy to do. But most people actually do a few queries from time to time, and we don't want to manually check every query. That would be a lot of time. So that doesn't work. So this metric is good, but most people have no objectives. So what we can do? Well, we can automate that. So we basically decided to give a score to each query. So if you think about a MySQL query, that would be very easy in your mind to think about, OK, if there's a lot of join, if there's a lot of where, it's getting harder and harder to do. If there's no index, it will be harder. So we did the same thing. Every request then got a score. And then we could put them into buckets, the same way we did manually, actually. If there is a low score, we put a low latency. If there is higher score, we put them here. If there is very too big of a score, we won't give an objective for them, like we just cannot. But remember also, availability was a problem, so we also put constraints over timeout. Obviously, we don't care if someone put a timeout of 5 milliseconds when we promise 50 milliseconds. So we did that, and it was way better. So the metric itself, if we think about alerting or everything, was not improved much, because we were already capturing most of the effects. The interesting part here is that everyone almost is included. We have a metric that represents everyone. And when people are not represented, then they know why. Because maybe the query is way too complex, so they can work on their query, make it more simple, or they can just change the timeout. If they cannot, because that happens, we can think of another solution later. And so now we have all our metrics good. So we're happy again. We're really, I see happiness, that's very good. So we're really happy. And this time we weren't, like it's still working for the moment. So we're really happy. But we spent weeks doing that. It was a long process. Like, was it really worth it monitoring all that stuff? So yes, we have a good reporting. Now we say, our data is like very good regarding latency, very good regarding content. All my responses are consistent. We're happy. We have good alerting. It was working already. Like we had technical metrics before. But like, what's coming on top of that? Well, the first thing is we could easily do automated mitigation, for instance, out of the box, like for free. We had this prop that is monitoring SLI. It's monitoring freshness. Now we have a contract with our product managers in front and say, OK, if it's more than 2 minutes delay, it's not good for us. Well, we have many data nodes. So we can use this probe and basically just discard some boxes when they're wrong without affecting anyone. So we did that, and it works fine. But we can go a bit further, and we can repair our own data automatically now, out of the box for free again. Like all this MapReduce job that we've put, it checks all the data. So if some errors are there, we can detect which reservation is bad and try to fix it. We cannot always fix it, but we can really often do it. We also now have a snapshot of all our data, 23 years of data, and we know it's good. Like, we should know it's good or not. Well, if it's good, then we just create a dump and erase the content of the data nodes daily. So there's no reason to check reservations that are very old on the data nodes, because we basically override this data on a daily basis. So it makes our life a lot simpler. And it's just for free, just because we did SLIs, basically. One last example, because we could go for a long time, is this probe we put on the stream. Like, OK, this reservation has been processed. It's still not being here. Like, what can I do? My SLI will go bad. What is the pain point here? Well, basically, we just can ask the guy for reservation service. Please, can you send it again? Like, I didn't receive it. I don't know why. Maybe there's a bug in the middle, and I will never receive it. It's possible. But maybe it's just lost because it happens. So I can ask him and re-enqueue everything. And so my data will try to get always better and better. The good thing about that is like when an actual incident happens, then there is some mitigation, some fix happening in real time before I get to the page, before I can react. So that's working well, but there is one thing very important that came out of all of that, which is not technical, actually. This is this. We had a huge problem when we started working on that. It's awareness. Basically, you have an HTTP service. This service has an availability or uptime SLOs, as you know. When those metrics goes down, people will react quickly. If your service is now at 99% of success rate, everyone will know about it. It's bad. They will react. It will be a high priority problem. But if your service is responding all the time, let's say close to 100% of the time, but is giving you bad responses, well, no one is reacting. It's very hard to make people understand that. The good thing with SLOs here is that we know that the product people, they want our system to respond with those limits. The data should be at worst 1 minute old, and you go on. You have many constraints. So one of those constraints gets violated, you know the priority of your problem. You can go, hey, guys, my technical metrics is bad. There's nothing I can do, but this SLI is validated. I'm basically breaching my contract with a system that are using me. So that was a big thing, a big change, actually, in our company. But the second thing is confidence. Yoann said trust this morning. I think it's just better. You want people to use your service. So they want the service to be responding. But if you know that your service is responding well all the time, if they can check that, it's good. Because I've never seen someone calling a service and checking that the response is actually good. I'm not even sure they can first. But if you tell them, OK, my service is always giving you good data, then it will be very easy for everyone to just go blind and use the service. And that's basically all I have to say. Thanks, everyone, for listening to that. And if you have any questions, that's the time.
I have a first question, if I may.
Yeah.
You mentioned success rate and availability.
Yep.
And you mentioned that availability would be measured based on different events that may fail, which are not just success rate. Could you elaborate more on this? What would contribute to availability, which is not success rate?
Oh, in the first slide. OK, so we consider, so it was the success rate of a reservation. So basically, in our system, and it's a bit of internal, we have availability being just the response, like the HTTP traffic. So sometimes we'll tell you, OK, it's a 200. I got your reservation. I'm processing it, right? But sometimes it's failed. And so I'm not responding you with a 500 because I got your reservation. I'm processing it. But it's not yet being processed. It's not yet done. Maybe it will fail actually later. And the guy using it will see, OK, this reservation is broken. It's nowhere. So you'll use tracing and everything to know where the reservation is, which state. But basically, at some point, it will fail. Let's say a basic thing, you get order stuff, and we have to process the payment at some point. If the payment gets broken, well, your reservation will never be processed, or maybe later. But the availability is still here. The service is running.
Thank you.
Hi. When you're talking about SLOs for a service, you have all these interdependencies of all the components which are involved, be it technical or from a process. So did you set up something that was a consequence out of a breached SLO internally? You said, okay, everybody has to look into it because you're breaching an SLO, that's fine, but is there something more than that? I mean, it's like an internal payback or something?
Yeah, so that's a very good point, because that's basically something we learned when we did the data SLOs at first. We were giving SLOs for the search service as an isolated system without having any metric or anything for the rest. So we were basically receiving a page like, oh, there is a problem. Like, you're basically having a problem to process fresh data, for instance. And sometimes it was just not actionable because another service broke. So that's where we made sure that we had monitoring of all the state before and be able to pinpoint the problem and either do it if it's in our system or contact the folks that are on another service and say, guys, there's a problem here, can you please have a look? The problem is most of the system, at least in our company, have a lot of technical metrics to monitor their problems, but SLIs and SLOs, especially for data, is on the way. It's really hard to get. So for instance, we have no way to know what's happening before the reservation service. So we just start from there. We have storage, we have several stuff there, but let's say we start from there, monitoring stuff, and if everything is wrong with the data, we just can go back from the reservation to the search to event server system later. I don't know if it answers your question, exactly.
No, I was wondering, let's say you have a service on the booking, on a search, whatever it is, an internal SLO with your latency, whatever, and don't want to finger point, but let's say the storage is not answering fast enough.
Yeah.
Now, internally, you maybe as an SRE for the booking service are responsible for the overall service, but you're having an impact because the storage people are not providing a service to you internally, which actually makes your service fail.
Okay.
How do you deal now with the storage people on that? So you get your SLO, you can prove that it's wrong, but then what? You can ask them politely to look into it, or is there something like payback or something?
Yeah. So we don't have this problem with storage, but we have some example like exactly fits your thing. Let's say the payment system goes down, for example. That can happen. That's a good one because we have a way to basically send them the alert from our system directly. Like, we have a SLI that is breached, and this is the contract we give to our users. But we also know why actually breach. And the technical metrics will go to the other folks, to the other system, and start breaking, like, guys, we cannot access your system, something is broken. So we cannot give them any ID, so they cannot use our SLI as a support. But all the technical metrics that we send them is what they use to know, okay, guys, you have a problem. And we can sometimes even not send a page when our SLO gets breached. Like, if we know exactly what the problem is, and it happens sometimes, then you just send a page to this system and wait for them to give a feedback before actually waking up your people.